All right, so previously we talked about the area inside the atom, which was the nucleus. That's where the protons and the neutrons live. What about the electrons, the third subatomic particle? Well, these live on the outside. So in the nucleus are the positive and then neutral neutrons, right? The positive protons and neutral neutrons. These contain all the mass, and on the outside contain the virtually massless electrons. And these electrons live in shells on the outside of a nucleus that are like an onion, right? Some of them are very closely held to the nucleus and won't be removed, while other ones are on the outside. And if you peel the onion just a little bit, those are the ones that you'll be removing. And so these ones that are in the outermost shell, these are the ones we care about the most because these are called the valence electrons and are the ones that are going to take part in chemical bonding. An atom's ability to use its electrons, to interact with others, to lose electrons, to gain more electrons. This outermost shell are the ones that are actually going to be doing this behavior. And it is the electrons that determine, for the most part, chemical reactions. I know we talked about nuclear decay previously, but to be honest, that's kind of a rare case of what we're going to be studying in chemistry. The vast majority of what we look at when it comes to how elements behave with one another is going to be directed by the electrons. Atoms tend to do things with their electrons, gain, lose, share valence in order to become more stable. This is going to be determined by the valence electrons. This general rule that they like to have 8 is called the octet rule and is a good one to keep in mind, especially for the most biologically significant smaller elements like carbon, oxygen, etc. So what about ions? So this is a really important vocabulary term to know. When an atom loses or gains electrons, it becomes an ion. And it's really essential here that when we start looking at ions, not to think that atoms always do this, right? So a cation is a positively charged ion formed when an atom loses electrons. And common ions are sodium plus, potassium plus, calcium 2 plus. But this does not mean that every time we see sodium, Na, it's always going to be Na plus. Sodium can take multiple forms. It can either have not lost its electrons, Na, charge of 0, or Na plus, charge of +1 because it's lost an electron. We are denoting two different things when we say sodium plus versus sodium, Na plus versus just Na. A cation is a positively charged ion, and anion is a negatively charged ion. And so here, chloride, Cl minus, this is showing that this chlorine atom has gained 1 electron, right? Could still be Cl. We see just plain Cl out there, but this particular ion is Cl minus. It has gained an electron. Knowing that ions can form and how to communicate about them is a really, really essential part of understanding chemistry and healthcare. So as far as whether an ion will form, because it's really important to predict what types of ions are likely to form, we look at group 1 of the periodic table. So this is the far left column, sodium, potassium, etc. These have 1 valence electron. When we look at the valence electrons, we basically say, well, as we get to the end of the periodic table, those are our noble gases, and after that point, we have core electrons, right? Those are the ones that end up being strongly held. But sodium and potassium, they go 1 further, and this is in group 1 of the periodic table, 1 valence electron. They could be satisfied 2 ways. They could gain 7 electrons to get all the way to that next noble gas, or they could lose an electron to go backward and be like the previous noble gas. They end up doing the lose 1 path to form a sodium plus or a potassium plus ion. That makes them stable. And when we see ions of sodium and potassium, the only type we see is Na plus or K plus. These are important electrolytes. When we get to group 2, magnesium is in group 2, and we look at it and we see now it has 2 valence electrons, right? Up to the noble gas, that's a full octet, and now 2 more means that it's got 2 extras. It could gain 6 to have another octet, or it could lose 2 electrons, and that's what it does when it forms an ion. Magnesium 2 is what's formed, Mg2 plus, by losing 2 electrons. Again, we still see magnesium containing its 2 electrons, but we also very commonly see Mg2 plus, and we don't see any other ions. If we look at group 17, this is the halogen group, so one away from our noble gases. And this theme of the noble gases, helium, neon, argon, etc., being our stable group, that's a theme that we want to think about, right? Chlorine has 7 valence electrons. If it gains one more electron, it will form Cl-, and that will have a full shell of 8 electrons. So that halogen group gaining 1 electrons, that is what it would like to do to become stable as well.